Good morning, everyone, and welcome to the Abrams Planetarium. Seems like I'm having a little difficulty with the speed this morning on the internet, so let's just see how this goes, and we'll wait in just a couple of minutes to see who comes online. In the meantime, I'm Craig Whitford, and I am the Meteorite Collections Coordinator at Abrams Planetarium. I've been volunteering at Abrams now into my 5th year, and this is something that we would thought we would try while everybody is cooped up inside. And this is another episode of They Came from Outer Space, a Facebook Live event for Abrams Planetarium, and I really thank you for joining us. This episode is going to focus in on lunar meteorites. And I know that we had talked about doing lunar meteorites along with Mars and Vesta, but after working on this a little bit and setting it up, I thought it best that we just stick with lunar meteorites today and see how that goes. That gives us some information for another episode, a little bit more in depth maybe. You get to see some specimens instead of just kind of gliding right through all the basic types of what we're going to talk about. It's achondrites. And Lisa, hello. I'd like to welcome you aboard. The director of the planetarium, Shannon Schmoll, will be handling most of the comments in that, and I'll try to keep an eye on those as well. In doing a little review from last week, we talked about the three basic types of meteorites. This is an iron meteorite, and you can see it has a polished half here, and then a half that has been etched with nitric acid that brings out the Widmanstätten pattern in the iron that only occurs in space. We can't replicate that on Earth at all. You can see the exterior of the iron meteorite there. So that's one of the three basic types. The most common of meteorites that come through our atmosphere and land here on Earth is the stony meteorite. And this is a nice example of one of the features that helps us determine whether it's meteorite or not. And that are these depressions that you see here, and those are called regmaglyphs. Regmaglyphs, or thumbprints. And that's where material has ablated off of it, has softened and burned out on its entry through the atmosphere. Stony meteorite, right there. And the third one, the third major type, is a stony iron meteorite called a palisite. And just look at those beautiful crystals. They're fractured, but wow, what an impressive meteorite, isn't it? And so those are the three basic types of meteorites. So you have stony iron, and iron. It goes through. The stony meteorites, if you were to slice one, or if you were to remove the outer crust of it, you would see that it has tiny bits of space dust. So those are chondrules in there, and as they melt, meteorites also show that the chondrules disappear into the matrix of the meteorite as they're melted. But those chondrules are just tiny pieces of space dust. One of the other key features for an stony meteorite are those shiny flecks of nickel iron that you might see in a meteorite. So hopefully we've got that covered, and just a little bit of a review. Again, a meteorite is a rock that was once a meteoroid and actually lands on the surface of Earth, and you can go out and pick it up. A meteoroid is a small, usually less than a meter rock orbiting the sun. A meteor is that visible streak that you see that happens as it's coming through Earth's atmosphere. A lot of friction happening, and it's burning. It's being illuminated as it comes through the atmosphere. An asteroid is usually a large, greater than a meter rock that is orbiting the sun. And our subject today is going to be on lunar meteorites and a very tiny percentage of meteorites that there are that come from the moon and from Mars. So with that, let's see if we have any other questions. Lisa, thank you. Where did I get it? The meteorites many of them been in the collection for over a century in some cases, other cases just decades. And the last meteorite that was actually added to the planetarium's collection prior to the last few years was in 1972. And we've added meteorites since then, especially Michigan ones. The Hamburg meteorite and the Edmore meteorite are the two most recent ones we've added to the collection. I'm going to be placing a website in the comments section of this Facebook Live event, and that is for Washington University in St. Louis. Randy Korotev there has built such a fine website. You might say it's the best, it's unique, it's the only one of its kind. He covers not only meteorites in general, things that you can look at, but his website is basically the repository for all the lunar and Martian meteorites that have been classified and named, including those that are still in the queue a bit to have work done on them. The website is filled with photographs and additional information on each of the meteorites, and really gives you a flavor for what has actually been blasted off the moon or Mars and has landed here on Earth. Well, lunar meteorites, as they imply, are lunar rocks that were ejected from the moon by impacts and later fell to Earth as meteorites. Now, I want to have a little caveat here, and that is that lunar meteorites are not moon rocks, like those that the Apollo mission astronauts brought back from the lunar surface. Moon rocks that they brought back are not legal to own or possess. They are in museums. They are in the meteorite collection, the Apollo meteorite collection at JPL, and they're studied for science greatly. The first lunar meteorite, the first meteorite to come from the moon, was discovered in Antarctica in 1979. So 10 years after the Apollo 11 moon mission brought back the first moon rocks from the surface. So how do lunar meteorites get here? Well, meteoroids strike the moon every day, just as meteoroids are coming through Earth's atmosphere every day. Most are very tiny, microns in size, and some occasionally larger. Those larger ones that create craters, the lunar escape velocity averages 2.38 kilometers a second. Okay? Mind you, there's very little gravity on the moon. That equals 1.48 miles per second, 1.5 miles per second. Only a few times the muzzle velocity of a rifle. When the lunar surface that is impacted by a meteoroid and reaches lunar escape velocity or greater, the debris created will actually leave the moon's gravitational influence. Most rocks ejected from the moon become captured by the gravitational field of either the Earth or the Sun and go into orbit around these planetary bodies. Over a period of a few years to tens of thousands of years, and perhaps longer, those that have been orbiting the Earth eventually fall to Earth, we collide with them. Those in orbit around the sun may eventually strike the Earth up to a few tens of millions of years after they were launched from the moon. So, as you know, the moon, although has two sides, the near side is the side that we see, the side that faces towards the Earth, as opposed to the opposite side, which is obviously the far side. And that is the side that we don't see. And we'll talk a little bit more about that as well. But let's... And how do we know they're lunar meteorites? Well, most of them have fusion crust, and that's something that we discussed last week as well. That would be the very, as you could see it here, the edge of this is black, and that's called fusion crust. Sometimes much of the fusion crust from lunar meteorites is much lighter or has a tint to it, something like that, because lunar meteorites are achondrites. Now remember I told you that those little blebs there that you see, the space dust, actually chondrules, okay? Well, achondrites don't have chondrules. These have come from planetary bodies that over time have a core and a mantle, and they're differentiated is a term that is used, and so they come from volcanic eruptions and things like that. And let's see. One of the major tests that they do is for cosmogenic nuclides, which will determine whether it's a rock or a meteorite, as opposed to one here on Earth. If you were to compare the two, all lunar meteorites that have been submitted for classification and which have been tested show evidence of this cosmic ray exposure. And that is one of the other ways that they know. Well, how many lunar meteorites are there? Well, according to Washington University's website, as of the end of January of this year, there have been nearly 400 named stones that have been recognized. Some of the named stones, though, are actually paired with other stones that have the same chemical makeup, may have come from the same location where they were found, and so that they're paired, which actually reduces the list down to about 150 specimens, give or take. The naming of lunar meteorites follows along the same line as any other meteorite. There has never been a lunar meteorite that has been seen to fall. So they have all been finds. Somebody's actually gone out and hunted for them. They've not been seen to fall, unlike Martian meteorites. There have actually been a few that have been observed falls. And so they can go right to the strewn field, which is the location, the elliptical location, where they may have fallen. And people hunt for them. Plus, no lunar meteorites have ever been found in North America, South America, or Europe at all. A couple of lunar meteorites have been found in Australia. Others, Botswana. The greatest portion of them, though, come from Northwest Africa, the desert there, and also Antarctica, the frozen desert, if you will. And so that's where they've been found. They're classified in the same way. You send them in for classification. Scientists look at them, review them, go over them, and then see where they might be chemically paired to other meteorites, and then they're grouped in that fashion. And the Washington University site will really, if you go to that, bear that out so that you can see where they all are. And see if we got any other questions here. So no. So what I'd like to do is actually show you a few meteorites so that you kind of get the feel for a variety of rocks that have been blasted off the surface of the moon. Some of them are actually related to Apollo landing sites, especially Apollo 16. So meteorites here from the same location where the astronauts brought back moon rocks have been found right here on planet Earth, which is quite amazing in and of itself, since the Apollo missions focused in on such a small area of the moon. And so it's hard to say where any of the meteorites that have fallen to Earth from the moon have actually come from, because we don't know. It's just that for the Apollo 16 mission, these rocks are very similar in composition to those that the astronauts brought back. Do we have lunar meteorites from the far side as well as the side that we see, the near side? Very hard to say, difficult. So we just look at them as a whole as lunar meteorites, and neither far side nor near side. And I see there's a question here: have meteorites ever been found in Japan? Oh yes, there have been meteorites from Japan. And meteorites, I believe, have fallen just about on every country in the world, given that 70% of the world is water, and the vast majority of meteorites wind up there. And as with regular meteorites, the stony and iron meteorites and things like that, lunar and Martian meteorites are just as best found on the frozen deserts or the hot deserts of the Earth. So, so with that, let's just have a look at a few specimens here. The first one I'm going to show you is one of those Australian lunar meteorites that was found. And this is, and you can see it's so tiny, it's actually only 3 milligrams in weight. And this is just a piece of the meteorite that was found in Australia. This one is known as Calculon Creek. And this is a basalt-bearing regolith breccia, that is, again, from volcanoes. This one had a fusion crust that was vascular. In other words, it had small, tiny holes in it, as do some of the lunar meteorites from Antarctica. The vesicles form from the release of solar wind implanted gases during the heating and melting of the exterior associated with its atmospheric entry into Earth. And so this is small, and just to let you know, size really doesn't matter in meteorites. There's so little of this material available to go around that many times you settle for what's known as a tiny micro of this. And a lot of people just collect tiny micros, just like this one. So Calculon Creek on that one. One of the next meteorites, and I'll pick this one up with a pair of tweezers so you can see it, is Northwest Africa 482. Let's see if that helps. Northwest Africa 482, you can see it has a gray matrix to it on there. And this is an impact melt breccia. It is absolutely one of the most beautiful lunar meteorites. The fusion crust on this was various colors of just a beautiful brown patina. And if you looked real close at this one, and I know, again, this is a small specimen though, you can see the line in it right there, which would be a glassy melt line going through that meteorite right there. The main mass, which is the main stone, this is only one stone, and this is a small slice of that stone, was only just over 1,000 grams. 1,000 grams. And so that's it. But a nice, beautiful example of a lunar meteorite. Another lunar basalt meteorite, again, volcanic in nature. And this would be produced, if you could see it, let's put this on the back again. And this one almost looks like a Martian meteorite in a lot of ways, the way it's set up. A gray matrix, almost a gray-green matrix in here. And this one had a dull black-brown fusion crust, where I mentioned a brown fusion crust on the last one. And let's see, 4936. I like to keep them well separated and everything. I'll pick this one up. This is known as Northwest Africa. And the number on it is 4936. So maybe if I hold it that way, huh? Gotta bring it in. Still getting used to the camera. Looks like an earth rock, doesn't it? Kind of a conglomerate of pieces and that. And well, and that's exactly what it is that when an impact occurs on the moon, it can go fairly deep depending on how big the impact winds up being, breaking up, fragmenting a lot of rock, and then bringing it back together again in space. All those dust particles and pieces of rock and everything come up. And this is actually a meteorite that has many pairings to it. In other words, there are other NWA numbers that are associated with this. This is a glassy breccia. It's similar to soil from the Apollo 16 landing site. It may have originated near that site, actually. So just a nice meteorite, nice lunar meteorite that would be called an individual. It's not a slice and it's not a fragment, although it is a fragment off of a larger rock at some point. So that's that one. Probably, well, undoubtedly, the most beautiful of lunar meteorites is the Northwest Africa 5000 meteorite, which is also a fragmental breccia. The main mass of that rock was 11.5 kilograms. So if I show you that, you can see all the angular and fragmented pieces, some round fragments in that of that. Kind of looks like the moon, doesn't it? White to light gray to dark gray class. And this is a cut, a slice of the meteorite. And it truly is one of the most beautiful. I've got another specimen here as well. And that actually may have some fusion crust on the right edge there. If you can see that kind of yellowish, milky color there, but just another specimen of Northwest Africa 5000. And that is actually one of those that I do up, you can see without some of the glare, gift boxes that I hand out, and featuring lunar meteorite right there in the center. Another meteorite that is associated with the Apollo 16 missions and the rocks that they brought back is Northwest Africa 6355. And this is a 2.5 gram slice of that meteorite that also has several pairings. This one was found in 2009 in Northwest Africa. And the original stone that this came from was just 760 grams. So not all that much. Even though there are a lot of stones, almost 400 different ones that have been classified, the total weight of the lunar meteorites don't add up to all that much. And so that's another one that came from the Apollo 16 landing site right there. Another very interesting lunar meteorite is Northwest Africa 6950, which is a regolith breccia with large class of mare basalt and gabbro. And let's see. And this one has kind of a yellow gray to it. You could see again another one of those glassy melt lines there on the surface of this. So gives you a little neat impression of what lunar meteorites look like. And in that, let's see what else I've got here that I can share with you. Probably this is known as Northwest Africa 8277. And as like that smaller rock that I had shown you, this is a little bit larger. This one weighs almost 12 grams. Okay, 12 grams. Now, when I showed you the Northwest Africa 5000 one, the original rock that this was cut from was almost the size of a bowling ball, basically. So pretty good size, and then they're sliced into full slices and then fractional slices and things like that, so that different universities, organizations, and also individuals can perhaps own a piece of the meteorite. So that's why it's really cut down to this size and makes it a little bit more affordable. Pieces like this are neat because you get to see the exterior surface. Now, this one, as I said, was also found in Northwest Africa. So the fusion crust on these that it obtains when it comes through the atmosphere has been ablated off probably over centuries or more of the sands rushing by the stone on the desert surface. But as you can see, since the desert surface is so light in color, these would be fairly easy to locate and find. And maybe in this area where the stone was found, there may have been numerous other stones from the same fall that came through. And that was actually a question that was asked last week is, can you have different stones come up from the same area or the strewn field where they may have fallen. And certainly over hundreds, thousands, tens of thousands of years, the surface has been pelted with rocks in the strewn field, the same one where similar rocks have been found. So if you were to take this one and slice it, that's what the interior of it would look like, similar to some of the other rocks we've looked at. But you can see all the fragmented pieces of stone and that from the impact crater have come to form these rocks. Pretty cool. Touching a piece of the moon, okay? And that's one thing that we want our patrons to do when they come to the planetarium, hopefully this fall, is you'll get to touch an actual piece of the moon, Mars, and the asteroid Vesta. So we'll have stations set up, and yeah, you can even take selfies if you'd like. Sounds pretty cool, doesn't it? Yeah. So let's see. I've got a couple of larger specimens here that I think we'll jump to that you might like. And this is just to give you a flavor of the lunar rocks and, you know, all the minerals that make it up. And the websites talk about all the different types of minerals that go into what is being ejected out of the surface and that. But here is a beautiful specimen. And that side has been polished. This side has not, so you could see it. And you can once again see all those angular fragmented pieces of other rock and that. The white material is called anorthosite for the most part, and that would come from the highlands from there. So this is Northwest Africa 10415. 10415. It has just a few pairings on it. The rock that this cut come from only weighed 164 grams. That was over 3 pieces, actually. And this is 5 grams, just over 5 grams. One of the other favorites I have here is a Northwest Africa 10823. And this is Glassy Regolith breccia. Again, you can see all the fragments that are in the matrix here. 202 grams was submitted for classification on this, and this is 10 grams of it right here. This has several pairings. You can see it hasn't been overly polished at all, so that you can see all the detail of that matrix in this lunar meteorite. Again, just imagine, prior to 1979, it was impossible to touch a moon rock. I believe that NASA allowed just a couple in the university collections or the museum collections to happen that way. And that. So with that, let's just check these. When you say the numbers of the rocks, the numbers I'm referring to is, for instance, the Sahara Desert. For the most part, the nomads that are searching out the meteorites out there aren't recording the GPS coordinates or anything as to where they're finding the rocks. Today it's different because they are, and also exporting rocks has become much more difficult. But those numbers relate to a consecutive order from, for instance, NWA stands for Northwest Africa, so that's considered a dense collection area. So a DCA is what they refer to that as. So as the first Northwest Africa meteorite was sent for classification, that would have been Northwest Africa 1. And at 10,000, they started over. They started at 10,001, 10,002, 10,003 to kind of reset it a little bit. But so those are just consecutive numbers as they have been submitted for classification. So, and are they common? Uh, Lunar meteorites represent about 0.1% of the meteorites that fall to Earth that we find. And since actual moon rocks owned by the Apollo astronauts aren't legal to own, that leaves us with lunar meteorites. And just in the last couple of years, there was a major fall that was discovered, and that reduced the price of lunar meteorites down for the more common types, or um, stone. So lunar meteorites are scarce. They are not common in a sense. Martian meteorites even more scarce than lunar meteorites from that standpoint. And Lisa's asked a question here: is this my job? I volunteer at the Abrams Planetarium, taking care of their meteorites and exhibits. And we were granted a grant from IMLS, which is a federal grant, to put our meteorite collection back on display, and created an interactive display, which prior to the coronavirus was scheduled to open in September of this year. We're still hoping to keep that schedule. We're continuing to work on the exhibit and everything, but it'll highlight the Michigan meteorites and tell stories about meteorites, and you'll be able to identify what is a meteorite and what isn't a meteorite. There'll be touch screens. Children make up the vast majority of those that visit the planetarium, and so it is certainly going to be children friendly and a great learning experience for them. So I'm a volunteer, so it's not my full-time job. Sometimes it seems like it, but I enjoy it, and look forward to the opening of the exhibit. And to finish things up a little bit, I want to get to some of the questions that were asked last time before we closed, and I've answered, I think, a couple of them in going through here, but let me just see if I can. There it is. Before I get to those, I have a little bit more, and actually to show you one of the pieces of our exhibit. This is, again, a lunar meteorite. This is Northwest Africa 12985. 12985. So everyone has a name, but this is actually the lunar meteorite that everyone will get to touch when they come to the planetarium, to Abrams Planetarium. And this will be in a holder so that you'll be able to stick your finger down in and touch the surface of the moon. And for kids, that's always a real treat. The director started something at the planetarium calling Hug the Moon. So when kids come in, they can grab our specimen on the moon and hold it to their chest. But you know, one of the theories about how the moon was created is Thea. Okay, there are actually two meteorites that are undoubtedly related. They're paired. That's what they refer to them as. That don't match any of the other known plots of meteorites. These are very much more similar to how Earth would be plotted and mapped out chemically wise and mineral wise. And that, you could see the flecks of nickel iron on this rock right here. That is Northwest Africa 6077. The other meteorite that's similar to that is Northwest Africa 5400. So if you want to do a little research today, best place to start is to put in NWA 5400, or Northwest Africa 5400, and I'm sure you'll enjoy the reading. It's fascinating what the theories are about that. These two paired meteorites are an interesting part of the solar system's puzzle. And that's what these meteorites each represent, is one more key to unlocking the question of the solar system. So Northwest Africa, 5400. Look it up and enjoy. So to go over a couple of things, and I just saw one of the questions that says, what's the biggest meteorite you've ever seen? And how big was it? Well, it'd be in one of the museums, I'm sure, but the largest meteorite on the face of the Earth is Hoba. And Hoba is in Namibia. It's an iron meteorite. It's nearly square. It was on a farmer's property. And over time, it has become a gathering place and things, but it is the largest meteorite on the face of the Earth at 60 tons. And if you take a look at this chart, you could see the Hoba meteorite right there. Hoba. Okay? That is the largest meteorite on the face of the Earth. This meteor right here would have been the size of the one that created the Arizona or Barringer crater out in Arizona. This size right there. Representation again. In 2013, Chelyabinsk, Russia, is the size here. These are all comparative sizes. So when you look at a Boeing 747, that is right here, and the Ticonderoga class cruiser, which is above, it gives you somewhat an idea as to what meteors can do. And this one in gray right here is Tunguska. That's the one that they still aren't sure whether it was a meteor or a comet that flattened the forest that day. But Tunguska was that size, roughly, they figure. So that's that. United States of America falls, meteorites that fall into the U.S. Now, mind you, tens of thousands of tons of stuff falling every day from space, landing on here. Most of it micron size, things like that. And next week we're going to talk about micrometeorites. But as far as named falls go, falls that we really see, probably less than a dozen. And if we're lucky, 3 or 4 of those might have names. Sometimes it's much less than that, sometimes more. But in the United States, it's very difficult because of all the vegetation to find a freshly fallen meteorite. It's been done. People get out there right away to look for them. But finding them in frozen areas, lake beds, things like that, or in the deserts are the best place to do. And those would all be finds and not falls. And again, I mentioned that meteorites from different falls can be found in the same location. It's happened before. If it's a fresh fall, you could tell the difference between a black fusion crust and a weathered fusion crust if you're looking for them. And the weathered fusion crusted stones look just like regular earth rocks. And one of my granddaughters had mentioned if there are any pink meteorites. Sorry, Kenzie, there aren't any pink meteorites, but there are space diamonds. So fun with that. And let's see. Oh, and Shannon's clarified the Hug the Moon project was started by Mike Davis, who's a graphic designer at MSU. So you could see that. But tell you what, once I'm offline here, I will put the website up for Washington University, and you could take a look at that. and have some fun researching. And if you've got kids at home that are looking for a project, have them look up Northwest Africa 5400, and maybe you can give them a hand and talk about one of the theories about how the Moon-Earth relationship works. So with that, I'd like to remind you that we have story time. Always check the Facebook page for Abrams Planetarium. We have experiment days that you could check out, and many other features. John French has taken us out to look at the skies, and I think tonight may be one of the last nights for the conjunction that's occurring. So if you get clear skies, which we don't see that often, it seems like, you can go out and take a look at that first thing in the morning before sunrise. As always, we're closed at this time. If you would like to make a donation to the Abrams Planetarium and all that we do, I'm sure Shannon will put a link right on the Facebook page so that you can do that. So once again, I wish you clear skies and keep your eyes to the skies. And this is Craig Whitford for the Abrams Planetarium. Have a great day.